Welcome to our section now on Automate Database Tasks for Azure SQL. A common goal for database administrators in many environments is to automate as many of their repetitive tasks as possible. This can be as simple as using scripting to automate a backup process, or as complex as building a fully automated alerting system. In this section, we will provide details of automating tasks to simplify the DBA's job. Methods include scheduling tasks for regular maintenance jobs, as well as multi-instance administration and configuration of notifications for task success or failure or non-completion. We will also discuss automation for PaaS, Azure SQL Database, and Azure Managed Instance. Stay tuned. Let's start by talking about how to automate database deployment. You can follow along using the listed URL here on this slide. To start, we will talk about how to automate deployments using ARM templates, Bicep, PowerShell, and CLI. Lastly, we will look at how to monitor deployments. Let's get started. Azure deployment methods provide a range of tools and interfaces for deploying and managing Azure resources, each suited to different use cases and levels of complexity. ARM templates and Bicep files offer declarative models for defining infrastructure, with Bicep providing a more readable syntax for lifecycle consistency, and ARM templates supporting orchestration and extensibility, such as running scripts post-deployment. PowerShell, through its Azure module and resource providers like AZ Compute, is ideal for modifying resources and retrieving status, and can also deploy ARM templates, blending imperative and declarative approaches. Azure CLI functions similarly, offering cross-platform support for both deployment and modification tasks. The Azure portal provides a user-friendly graphical interface and allows users to export ARM templates for reproducibility. Automation and CI/CD workflows, Azure DevOps and Azure Pipelines streamline deployment processes. These methods collectively support a wide range of scenarios, from manual configuration and real-time updates to full-scale infrastructure automation, making them essential tools for cloud engineers, DevOps professionals, and DBAs managing Azure environments. Azure Resource Manager, or ARM templates as JSON-based declarative files used to define and deploy Azure resources consistently and efficiently. Unlike imperative models like PowerShell or Azure CLI, which require step-by-step instructions, ARM templates specify the desired end state, allowing the Azure platform to determine the deployment process. This declarative approach simplifies automation, supports dependency management, and enables parameterization for flexible deployments. ARM templates can be deployed via Azure DevOps pipelines, Azure portal, or even custom deployments through the Blade or command line tools, making them versatile for various environments. Benefits include repeatable infrastructure provisioning, reduced human error, and streamlined management of complex resource groups. Use cases range from deploying SQL VMs with storage to full-scale enterprise environments, often leveraging Microsoft's Quick Start templates like those found in GitHub. Using Azure Resource Manager or ARM templates for deploying cloud infrastructure has a lot of benefits. ARM templates are JSON-based files that automate resource provisioning in Azure, ensuring consistent and repeatable deployments across environments. They can be run multiple times with the same result, which is ideal for managing infrastructure throughout the development lifecycle. ARM templates simplify orchestration by automatically handling the order of the resource creation and deployment components in parallel when possible. This helps to speed up the process. Their modular nature allows developers to split and combine the templates as needed, making them flexible for various deployment scenarios. Templates can be exported from the Azure portal, which is useful for learning syntax, disaster recovery, and documentation. Authoring tools like Visual Studio Code and Visual Studio provide rich support for template development, including IntelliSense and syntax highlighting. ARM templates are especially beneficial for complex deployments involving interdependent resources such as virtual machines, network, and storage, and they support extensibility by allowing post-deployment scripts to run on provisioned resources. Azure Resource Manager or ARM templates are a powerful declarative tool for deploying complete sets of Azure resources in a single, consistent operation. Unlike imperative models such as PowerShell or Azure CLI that require step-by-step instructions, ARM templates define the desired end state of the infrastructure, and the Azure platform determines how to achieve it. These templates support built-in dependencies and parameterization, allowing flexible deployment configurations at runtime. They can be exported directly from the Azure portal or sourced from Microsoft's Quick Start templates on GitHub, making them accessible even to database administrators who don't write templates from scratch. Benefits include automated, repeatable deployments, reduced human error, and simplified management of complex environments. Use cases range from provisioning development environments and deploying multi-tier applications to integrating with Azure DevOps pipelines for CI/CD workflows. An Azure Resource Manager template is a JSON document that defines the infrastructure and configuration for deploying resources within an Azure environment using the Azure Resource Group. The required fields in an ARM template include schema, which references the schema file provided by Microsoft to validate the template structure, content version, a user-defined version number for tracking changes, and resources, the only mandatory section that specifies the Azure services to be deployed. Optionally, but beneficial fields include the API profile, which helps target specific API versions for different environments, such as national or commercial clouds, parameters, which allow customization at the deployment time, variables, which specify expressions, functions, which enable reusable logic, and outputs, which return deployment results. These elements make ARM templates repeatable, modular, and extensible. These are ideal for consistent infrastructure deployment, disaster recovery, and automation across environments. ARM templates define the desired state of the infrastructure in a JSON format, allowing for consistent, automated, and scalable deployments without prescribing the exact steps. Unlike imperative models such as Power BI or CLI scripts that execute tasks sequentially, the PowerShell command new Azure Resource Group deployment is ideal for users in Windows environments and integrates well with other PowerShell scripts, offering rich object handling and error management. It uses parameters like name, which works with the resource group name, template file, and that works with our template parameter file to define the deployment. And on the other hand, the Azure CLI command, AZ deployment group create, is cross-platform, it's lightweight, and it's better suited for shell scripting and CI/CD pipelines. It uses resource-group and the template file and supports the parameter files via parameters. While PowerShell is preferred for its scripting depth and object-oriented output, Azure CLI excels in speed, simplicity, and compatibility across operating systems. Both tools support ARM templates and parameter files, but the choice depends on the user's environment and the scripting preferences. Azure Bicep is a domain-specific declarative language designed to simplify the deployment of Azure resources. Bicep is a streamlined alternative to traditional ARM templates, offering a more concise and readable syntax that improves the authoring experience, especially when used with tools like Visual Studio Code. It automatically detects dependencies between resources, ensuring that they are deployed in the correct order and without manual orchestration. As an infrastructure as a code tool, Bicep enables consistent, repeatable deployments across environments and supports modular design and code reuse throughout the development lifecycle. While not a general-purpose programming language, Bicep excels in scenarios such as provisioning virtual machines, networks, and storage in a declarative format, making it ideal for DevOps workflows, disaster recovery setups, and scalable cloud infrastructure management. Here we see how to target deployments using Azure Bicep files for Azure Resource Provisioning. We see 3 deployment options: using a local Bicep file via the template file parameter, deploying remote Bicep files, currently unsupported, and deploying template specs, which is unsupported via the Azure CLI, but possible using the Microsoft.resources/templates specs resource. The code demonstrates how to deploy Bicep templates to different scopes, such as resource groups, subscriptions, management groups, or tenants. Azure Bicep simplifies infrastructure as code by offering a more readable and maintainable syntax than traditional ARM JSON templates, automatically handling resource dependencies. Its benefits include consistent deployments, improved developer productivity, and seamless integration with Azure Resource Manager. Here we showcase the strengths of Azure Bicep as a domain-specific language for deploying Azure resources. Bicep offers continuous full support for all Azure resource types and API versions, allowing developers to immediately use new features without waiting for tool updates. Its simple syntax makes Bicep files more concise and readable compared to equivalent JSON templates, and it's easy to use even for those without prior programming experience. The rich editor experience, especially when using the Bicep extension for Visual Studio Code, provides type safety, IntelliSense, syntax validation, and inline help, which streamlines development and reduces errors. These features make Bicep ideal for infrastructure as code scenarios, such as automating cloud deployments, managing consistent environments across subscriptions, and version controlling infrastructure configurations throughout the development life cycle. And as you can see here, you can see a little demo of Bicep going on live for us and how easy it is to work with. Now we see a side-by-side comparison of the same deployment logic. The Bicep file on the left showcases a clean, concise syntax for defining parameters and resources, making it significantly easier to read and write than the verbose ARM template shown on the right. Bicep simplifies infrastructure as a code, as you can see, by offering continuous full support for all Azure resource types and API versions, allowing developers to use new features immediately without waiting for tooling updates. It's easy to learn, requiring no prior programming experience, and integrates seamlessly with Visual Studio Code through a rich editor that provides type safety, IntelliSense, and syntax validation. These benefits make Bicep ideal for scenarios where clarity, maintainability, and rapid iteration are essential. Now let's look how we can deploy Azure resources using Bicep templates through two command line tools, Azure PowerShell and Azure CLI. The PowerShell command new-AZ resource group deployment targets a resource group called sampler.rg and deploys a local Bicep file called main.bicep while allowing parameters like administrator login to be specified. Similarly, the Azure CLI command, AZ deployment group create, achieves the same deployment using a JSON template file. Both methods support deployment scopes such as resource groups, subscriptions, management groups, and tenants, offering flexibility for different organizational needs. With PowerShell, users can save the main.bicep file locally and execute the deployment directly, while Azure CLI provides equivalent functionality across platforms. These approaches benefit infrastructure as a code workflows by enabling consistent, repeatable deployments, simplifying resource management, and supporting automation in development, testing, and production environments. Here we are using the Azure Command Line Interface, or CLI, to manage Azure SQL Database resources to showcase two commands, one to create a SQL Server and another to configure a firewall rule. The first command, AZ SQL Server create, sets up a new SQL Server by specifying parameters such as the server name, the resource group, the location, and the admin credentials. The second command, AZ SQL Server firewall-rule create, adds a firewall rule to allow access from a defined IP range. These CLI commands are ideal for cross-platform scripting and automation, enabling users to manage Azure resources interactively or through scripts. You can run commands through the terminal using the interactive command line prompts or scripts. Here are two PowerShell commands from az.sql, the module used to manage Azure SQL resources. The first command, get-az SQL Server, retrieves details about a specific Azure SQL Server within a resource group, while the second command, new AZ SQL Database, creates a new Azure SQL Managed Instance database on that server. These commands exemplify how Azure PowerShell enables automation and consistency in cloud resource management. Both Azure PowerShell and Azure CLI are cross-platform tools that work on Windows, Mac, OS, and Linux, with the main difference being their shell environments. PowerShell uses its own scripting language, while Azure CLI is built on Bash. These tools are ideal for scripting repetitive tasks, integrating with CI/CD pipelines, and managing our infrastructure as code. They offer a lot of flexibility, and they're very efficient for developers and admins who want to deploy and maintain Azure environments. Now it's time for our knowledge check. Question 1. What language are ARM templates written in? Answer: JSON. Question 2. If you want to pass in the region of a resource group deployment, which option should you include in your template? Answer: parameter. Question 3. Which element of a template allows you to build dependencies into resources? Answer: depends on. Now let's see how to deploy an Azure SQL database using an Azure Resource Manager template. Now we're ready for lab number 11, deploy Azure SQL Database using Azure Resource Manager. So lab number 11 is all about using a template to deploy Azure. And what you can do in this lab is you can go out to the web browser. And in the web browser, what you want to do is paste in the link here to get out to GitHub. And from this, you can get the lab information. We have quick start templates that are out there that you can deploy here, a SQL database. As a matter of fact, I'm going to deploy a SQL database plus also, of course, the server that goes along with it. The database server that goes along with it here. It's going to be in the interface. And once you're here in the interface, what you're going to see is I can do a whole bunch of stuff here off to the left, and we're going to use a quick start template here. And there's a lot more that I can choose from on this list. And I think you're going to enjoy going through that list and seeing different objects that you can deploy related to our SQL database. The one that's there on the right, however, has the JSON file and the template file and some bicep files here too. But what we're going to do is I'm going to go right-click this and I'm going to go into a new tab, and that will show us what the JSON looks like. And you can read it a little bit there, and we're going to deploy this in a bit here when we get a chance. And so here is what it has. It has a schema, it has parameters that you can adjust during the installation. It has resources that it's using. As you can see, our server, our database, a couple of resources out there. So you can take a look at the code, but even better, since we're talking about using quick start templates, is that we can scroll down and we can deploy to Azure. So we can click on that. And what we need to do is it'll ask us to authenticate to Azure. And after you click on deploy to Azure, and then you can click right here, and it will give us the configuration options to do. So what happened here is I went down and I clicked on deploy to Azure, I authenticated, and it opened up the screen that you see right here. And now you'll also notice as you go down, you still have to put in some information, the resource group, the subscription, and all of this still comes into play here. And we're also going to be using the resource group DP-300 labs in the West region as before. And you can see it's going to create a unique string. And then from there, you can give it a server name based on the resource group that you're part of there in the SQL resource group. And I have a sample database that I'm going to create to do this, but I'm going to do it and I'm going to go in and scroll down, and you could right here make certain that you have the administrator logon that you want to use. And of course, make certain you include the password for this account. And what I'm going to do is before we launch this, I want to see if I can go and visualize this. So I'm going to visualize this, and it may not be as great as we think it could be, but we could click on it. And since it's just one server, it's not that elaborate, but it may take a little bit to open here. And you can see it just shows you the visualization here. And it's not anything to really, it's not as elaborate as it could be because it's only one server. We could also go into parameters, and I can focus on those just on the sample parameter database there. There's the admin login option there too. The password, all of those are considered password, but the password is like, you can completely see it, so it's not top secret. So be careful with that. And then I could also edit the template. And when I edit the template, the parameters, the name of the database, all that information is kind of put together. So a bunch of stuff that you could use here that's available in our Quick Start template. You could also load a file. You could download it. You can make changes to it. You could save it. You have a lot of options to choose from here. But what I'm going to do is I'm going to go ahead and click on Review and Create. So it's going to take a moment. It's going to go through the validation process. And once it passes validation, and we're going to look to see if we have any red dots anywhere to address those. But if it doesn't have any red dots on it, I'm going to go ahead and click Create because it passed validation. So this will take a little bit to process. It's going to create this database. And it does create a database server with it because the database is going to ride on that server. And it's going to take a little bit for it to do this. And we can see that it's going to call it kind of a random name. And you could go into the operation here. You can see the template. So if you want to, you can see the template that it's making. You can also deploy it. You can copy it. You can download it. And like I said earlier, it's a good way to kind of see, even though it's through the GUI, I could use this to see the JSON and see when the deployment's completed, the process that it went through, and this was really fast. So I'm going to go out to that resource right now, to the resource group. So that's a way to go here. And I can see the deployment details there. You can see there's a server. You can see the names on it. So I'm going to go into Azure now, and then I'm going to click on Azure SQL, and I'm going to go find that resource that it created, which is on my page 2, I think. And I made one a little earlier thinking this would take a while to run, but it was actually pretty fast. So I will see if I can find it on my list. And maybe I didn't hit the refresh on this. So let's see if I can find it. Maybe it's on page 1. See where it went. It doesn't look like it's there, so it should be maybe on, take a look a moment here, maybe 2. Didn't refresh properly. But we can see here I have one server, and then there's the sample database on it. So very, very easy. I can go out to that sample database and I can take a look at it. So the database that's riding on top of our server here, I can go into the query editor here and I can see if I can run my query against it. I may have to make some additional adjustments, as you may remember. Knowing the password is the key, and then being able to add my client to the acceptable whitelist here to be able to get through that firewall. And that would be one thing. And I could have it update the firewall rules here, which I did by clicking the OK button there. It'll give me a minute, then it gets me in, and I can see what I have permission to be able to see. Tables, views, stored procedures. Notice I have not a lot of capabilities in there here at this point. So if I go back into the overview there, I might have to connect to this via my Management Studio. And now I can do that. I just have to fire up the Management Studio, which might be worth it. Let's see how long it takes to do this. And so we have the server here, limited capabilities through the query editor window here, but some capabilities. It's fairly narrow capabilities here. And what we can do is we can go back into overview. We can pick up that server name again, an easy way to do it. It might be helpful to copy that. And then we'll click into Azure here and we'll go back and find the server. And we can get a little bit of an overview of that also and see how it looks. Looks like a lot of setup it did for us automatically here. We got the sample database on it here. We can click back onto that. So it's kind of an easy way to get into it if I need to from the server. We can also go in and make a lot of adjustments from here if we'd like to be able to do that. So the server, you can see the databases on it. We could add more databases to it too. So it's easy deployment through that template, as you saw. Very, very easy deployment through that template. We also got a lot of this from GitHub, and the templates there, very easy to use. And now my Management Studio is ready to use. I'm going to paste in the name that we copied earlier there. I'm going to get authenticated to it using the Microsoft. Actually, I'm going to use SQL Server Authentication. And maybe I shouldn't use that one. I'm going to try Microsoft Enter ID, actually. And I'll put my username in. So I have to remember my account. So maybe I'll try another option here. We'll get it authenticated. I have to trust that server. And now I'm going to connect to that. Ooh, Okay, so I have to know which authentication to use and which name and number to use. So we may have to do a few more things to kind of get this authenticated, but you can see how I could do that here. So I didn't really say, I don't think I set up the SQL authentication. I might have to use one of my other logins here to make this happen. So we'll have to come back to this. But the idea here is very similar to what we did with our other labs when we can log into it and get connected and have more options to manipulate the database. I think you may consider this deployment as a really good option to work with. It's easy to use, easy to deploy, and probably took all of maybe a minute to do it. So it was very, very fast. So definitely take a look at the quick start templates and take a look at how you might want to use this to do your deployments. And I hope this section was helpful. Welcome to our section on how to create and manage SQL Agent Jobs. If you'd like to follow along, we have a link here on the slide that you can use. Database systems need regular maintenance, which includes tasks like making backups and updating statistics. Maintenance may also include regularly scheduled jobs that execute against a database. Some common examples of these jobs would be to extract, transform, and load data from a transaction processing system into a data warehouse. In SQL Server and Azure SQL Managed Instance, the SQL Server Agent Service allows you to schedule jobs to perform these maintenance tasks, as well as providing other management functions. In this section, we will focus on maintenance activities that you should perform and how to configure notifications and alerts. Stay tuned. SQL Server maintenance activities outlines essential tasks that ensure the health, performance, and reliability of databases. These include regular database backups for disaster recovery, index maintenance to optimize query performance, and statistics updates to support accurate query optimization. Equally critical are database consistency checks using the dbcc checkdb command, which is a way to detect corruption across the entire database. While some organizations perform these tasks nightly, production environments often spread them across the week due to their intensive I/O nature, typically scheduling them during off-peak hours like weekends. Maintenance plans are created as an integration service package and help automate and schedule these operations, while open source scripts offer flexibility and control. Together, these practices form a robust strategy for maintaining SQL Server environments, supporting both high availability and efficient performance. This is a great outline here of best practices and task flows for creating SQL Server maintenance plans, emphasizing the importance of regular database upkeep to ensure performance, integrity, and reliability. We recommend avoiding the database shrink task to prevent fragmentation, staggering backups to manage storage load, and creating separate maintenance plans tailored to specific tasks or databases. For example, one for system databases and another for user databases, and a third for handling large databases individually. The flow chart here details essential tasks such as checking database integrity, reorganizing and rebuilding indexes, updating statistics, and performing full backups. These tasks help maintain data consistency, optimize query performance, and manage storage efficiently. Maintenance plans are especially useful in enterprise environments where automation and consistency are critical, and they can be scheduled to run during off-peak hours to minimize impact. Following these practices ensures that each database receives the appropriate level of care, reducing the risk of data loss and improving overall system health. The SQL Server agent plays a critical role in automating and scheduling tasks within Microsoft SQL Server and Azure SQL Managed Instance environments. SQL Server agent runs as a background process and stores job information directly in SQL Server. Jobs consist of one or more steps, each executing a specific task, such as backing up a database. It supports flexible scheduling where jobs can run on demand at set times or in response to a specific event. For example, you can automate nightly backups across company servers and configure alerts to notify administrators if a job fails. The Job Activity Monitor provides real-time visibility into job status and history, helping DBAs troubleshoot failures and optimize performance. Alerts are automated notifications triggered by specific system events or thresholds, enabling proactive issue resolution. For example, alerting when the disk space is low could be helpful. Operators are designated recipients of these alerts, ensuring the right people are informed of critical events. Proxies allow jobs to run under alternate security context, enhancing security by limiting access to sensitive resources while maintaining functionality. Lastly, error logs capture system-level and agent-related events, serving as a vital tool for diagnosing issues and auditing system behavior. Together, these components form a robust framework for managing, monitoring, and securing SQL environments, and together provide a structured and efficient way to manage database operations. Some of the benefits that we get from this include reduced manual effort, consistent execution of maintenance tasks, and proactive issue detection. SQL Server Agent enables multi-server job management, and it does this by allowing one server to act as a master server that distributes and executes jobs across multiple target servers. The target servers periodically connect to the master to update their job schedules. This ensures consistent and centralized execution of tasks like database maintenance. This setup is especially beneficial in enterprise environments where managing jobs individually on each server would be inefficient. It reduces administrative overhead and improves consistency, and it simplifies deployment of tasks such as backups, index maintenance, and integrity checks. A best practice is to create separate maintenance plans tailored for specific databases or tasks. For example, one plan for system databases, another for the user databases, and a third for our large databases that require special handling. By defining jobs once and then pushing them out to all the target servers, organizations can maintain uniformity and streamline operations across their SQL Server infrastructure. SQL Server Agent can be configured to send task status notifications and alerts, enabling proactive monitoring of job execution and system health. Notifications can be triggered on job completion, success, or failure, though most DBAs opt to notify only on failure to avoid kind of that alert fatigue. Alerts can also be set up to monitor SQL Server error logs, performance conditions, and WMI events, such as high CPU usage or low page life expectancy. This allows operators to respond quickly to critical issues. To enable email notifications, both database mail and the SQL Server Agent Mail profile must be configured. This setup is especially useful in a multi-server environment where consistent job execution and system reliability are essential. Use cases include monitoring backup jobs, detecting storage failures, and managing availability group failovers. By combining notifications and alerts, DBAs can ensure timely responses to failures and maintain optimal performance across SQL Server infrastructure. Operators in SQL Server and Azure SQL Managed Instance are like aliases for individual users or groups configured within the SQL Server agent to receive notifications and alerts. Operators typically map to administrator groups, often via email distribution lists, ensuring that job completions, failures, or system alerts logged in the error log are communicated reliably. This setup provides redundancy, so if one person is unavailable, others in the group still receive the alert. It also simplifies maintenance. When someone leaves the organization, they can be removed from the group without needing to update every SQL instance. The benefit of using operators lies in its centralized and resilient alerting, which improves operational awareness and response times. A common use case is notifying a DBA team when a critical backup job fails or when performance threshold is breached, enabling timely intervention and system stability. SQL Server agent alerts can be configured to proactively monitor server performance by triggering notifications based on specific metrics, such as CPU utilization exceeding 90% for 5 minutes, or maybe page life expectancy falling below a defined threshold. These alerts are essential for maintaining system reliability and enabling timely responses to potential issues. SQL Server Agent reads the error log and then raises an alert when the prescribed error number or performance conditions are met. It then goes in and notifies designated operators about the failure. This functionality extends to monitoring Windows Management Instrumentation or WAMI events and SQL Server errors of level 18 and higher, as well as critical events like storage failures or availability group failures. A common use case is automating alerts for performance degradation, ensuring DBAs are informed of conditions like low page life expectancy or high CPU load. Best practices include setting meaningful thresholds, avoiding alert fatigue by targeting critical conditions, and ensuring alert configurations are regularly reviewed and notifications are properly routed to the responsible people. Now it's time for our knowledge check. Question 1. What has to be configured before the SQL Server agent can send email? Answer: a mail profile. Question 2. Which system database stores SQL Server agent jobs and their information? Answer: MSDB. Question 3. Which operation recalculates the statistics on an index? Answer: rebuild. Join me now to see how to create a CPU status alert for a SQL Server. So welcome to our Lab 12, and we're going to spend some time showing you how to create a CPU status alert here in SQL Server. And this is actually going to be done inside of Azure. So we're going to head over to Azure right now, and I'm going to go back into our Azure SQL. And it's been a little bit since we've been in here. And what we'll do is we're going to go look for the AdventureWorks LT lab number 2 database there. And I'm going to use this one. And once we get in here, we're going to go ahead and take a look at how to make an alert. So like I said, this is very short. It's to the point. It's in, we're going to look in the database here. And we're going to do is we're going to see if we can find alerts in here. And I'm just a little further down in here. Right here is alerts under monitoring. So once I get into alerts, there's a big blue button I can use to the right there. It's called Create Alerts. So I'll use that. And there's a lot of alert rules that we can create. So this is just one of many. And they have some popular ones here up at the top, and we're going to use the CPU percentage there. But we could also take a look at the DTU and more. So we can go into and see signals. So we might find some more in there, but I'm going to pick the CPU percentage right here. And then what we're going to do is we're going to go configure it from right here. Now the default that comes up is the one that we want to use because it's really the best practice setting. So there isn't really any guessing about it at all. If I want to do static, I have it set to aggregate via the average. So when the average CPU is greater than, less than, equal to, I can adjust that if I'd like. A certain percentage, I could have it fire off an alert. And I can also put the threshold in. And that's when you want the alert to fire off. So that's an excellent option. It's the default. The default is a good one. This is the one we want to work with. Notice it's going to evaluate every 1 minute, although I can adjust that and have it look back over a period of time, and I can adjust that too. But the defaults are here. I could also add additional conditions if I wanted to add a few, and I could. One of the other options you should consider is that of the dynamic option. The dynamic option is actually pretty good. So I'm assuming that a good option to pick here, and it has been quite a standard for a very long time, is that when the CPU usage gets above 90%, it signifies a bottleneck. But I could also set it to dynamic, and I can let Azure figure it out. So whatever you'd like to set up here, Azure can figure it out for us, and it can raise the alert. So this one is one that will kind of go with the flow in the monitor here to do dynamic, but static is the way we want to go, at least right now. So I'll choose that. And what I want to note here is there's a cost to this, so keep that in mind. There's a cost with this when I click this in, and I have the action groups that I'm going to create right here. So be aware of that. I'm going to create a new action group. And as I create the action group with the alerts bundled together, then I can go in and roll it out on different databases here if I like to do that. And you're going to see the resource group, and then I'm going to see that it runs actually globally. So I don't know if there's a way, I guess we can make this a little bit smaller here, it looks like. But the idea here is wherever it may happen, you can use the defaults that will help narrow it down to your region. So there we go, we can narrow it down that way. Then here's my resource group. And so it depends on what kind of resource we're monitoring. But the resource group I'm going to pick is just my own region. And then for the action group name, I'm going to call it the email group. And we'll go ahead and create a little email group there with this. And I'll also put in a unique name for it. And I'll test this. I tested this out a little bit ago to make certain it works with our workloads here. And you can see the names have to be unique, so I have to add it in that way. And then what I'm going to do is I'm going to click on notifications, and this is where I can say how I want to be notified. And since it's the email group, I want it to maybe do a text message, a voice message, a message maybe through a couple different options there, voice, SMS, Azure mobile notification, a lot of different ways you can be notified. You can put your phone number in, it can call you. Maybe you want to go to your mobile app for notification. So you can decide how you want to get notified. But we could set up email here very easily. And then what we can do is we can go ahead and give this a name right here. So I'm going to just call it something unique. So let me do that. Let me pull this back up and get into the action part of it. Let me go previous, and let me see if it'll let me alter that. And I can put in a fake email here if I'd like to do that for right now, just to get this to move forward. As a recipient of this email, this person will automatically get an email letting them know that they've been added to the group, so that would be part of this too. So let me go ahead and OK that, and then that should get it working here, and I can move forward. And I'm going to click on Actions, and then when it fires off, when the alert is raised because the CPU usage gets higher than 80%, besides notifying someone, what else do I want to have happen? And I could have it run an automation runbook. It will talk about those coming up. A function, I could have it run maybe a record, record something. I could have it work with the query store here. You can also see if there's anything else that you want it to do when it fires off. You can tell it what you'd like to do by choosing from the list here some of the options that it has. And then, of course, I can tag it so we know who created it, who it belongs to, where the cost goes. And then I can create the action group. And so that action group, once it's created, notice we have it here, and we can get back into it. And if we go back into the alerts section, we may notice eventually it will show up here once it's created. It'll take a moment. And once we've done our refreshing, we may see it come up. So this lab gave you a little look at how to make an alert. And as you can see, it's very easy to do. It may just take a bit for it to show up here once it's processed. And we'll be able to see the action groups in just a bit here. We can find them right here. So not too bad. And okay, so we saw how to do this. This is part of our lab, the lab that we just worked through here, which was part of our lab 12. And it was a very short one. Thank you so much for watching this video, and I hope to see you in our next one. Welcome to our section on how to manage Azure PaaS tasks by using automation. If you'd like to follow along, please see our URL here on our slide. We have learned about some of the capabilities of SQL Server Agent and SQL Server and Azure SQL Managed Instance. In this module, we will learn about Azure Automation, Logic Apps, and Elastic Jobs, 3 approaches for automating jobs in PaaS. We will also learn to monitor automation tasks to make sure that they're working properly, but we will start off talking about Azure policy. Let's see how administrators can enforce governance and consistency across our cloud environment by using Azure policy to define and apply rules to Azure resources. Similar to how group policies or GPOs have been used in Windows Server environments to manage security and enforce standards like password complexity or mapping network drives. Azure policy brings that same centralized control to the cloud. It allows organizations to enforce naming conventions, restrict resource types or deployment regions, and combine multiple policies into initiatives for broader compliance goals. The benefit of Azure policy lies in its ability to automate governance at scale, ensuring resources adhere to organizational standards without manual oversight. A typical use case might involve preventing deployments of virtual machines in unapproved regions or enforcing encryption on all storage accounts. By blending GPOs for on-premise consistency and Azure policy for cloud governance, organizations can achieve unified control across hybrid environments, reducing risks and improving operational efficiency. So this slide highlights the strategic use of multiple Azure subscriptions to optimize billing, security, and resource isolation across large organizations. By assigning subscriptions as billing boundaries, companies can track costs back to specific departments, improving financial accountability and budget management. Separating internal business systems from customer-facing resources through distinct subscriptions enhances security and operational clarity. These subscriptions can be grouped under a management group, allowing centralized policy enforcement and compliance monitoring across the enterprise. This setup is especially beneficial for organizations managing diverse workloads, enabling consistent deployment, streamlined governance, and reduce risk of cross-environment interference. Use cases include isolating sensitive internal data, managing customer services independently, and applying uniform policies across multiple teams or business units. Tags are metadata in the form of a key:\value pair, and it's used to enhance the organization and management of Azure resources. Beyond just naming conventions, tags can be applied at various levels: subscription, resource group, or individual resources, and are visible in the Azure portal, PowerShell, Azure CLI, and ARM templates, making them versatile for both manual and automated workflows. Azure supports up to 15 tags per resource, and common examples include cost center, environment, the creation date. Tags will also help to categorize resources for financial tracking, operational tracking, clarity, and compliance. Here's a practical example from the Azure portal on our slide where the tag is like environment:development and the cost center is cost center:finance. Both of these are used to help contextualize the resource. The benefit of the tagging included here improves cost management, resource filtering, and can be used for policy enforcement, like filtering all development resources for updates or tracking expenses by department. Use cases range from identifying product versus test environments to ensuring resources meet audit requirements. Tags are a lightweight yet powerful tool for maintaining clarity and control in complex Azure deployments. Azure Automation has powerful capabilities for streamlining operations across cloud and hybrid environments. It enables the creation of a regularly scheduled task that can target any Azure resource or even on-prem virtual machines, making it ideal for automating routine processes and reducing manual effort. Azure Automation is particularly useful for performing maintenance activities on Azure SQL databases, ensuring database health and performance. It also helps enforce consistent configurations across multiple virtual machines, minimizing configuration drift and enhancing manageability. For more granular control, Azure Automation supports process automation, configuration management, and full integration with Azure platform features like role-based access control and Microsoft Enter ID. This makes it a robust solution for managing both Azure and on-premise resources, especially in enterprise environments where consistency, compliance, and efficiency are critical. Here we have outlined the 4 foundational elements that enable powerful and secure automation in Azure. We have runbooks, modules, credentials, and schedules. Runbooks are the core units of execution and can be created using PowerShell, Python, or graphical interfaces, with PowerShell being really the most common option to choose from for managing Azure SQL resources. They automate tasks like VM provisioning or database maintenance and improve consistency and reduce manual effort. Modules extend runbook functionality by importing necessary libraries, such as the az.sql module for the database management of SQL and more, ensuring scripts have access to the right commandlets. Credentials securely store sensitive information like passwords, allowing runbooks to authenticate without exposing secrets in code, which is vital for tasks like accessing secure databases. Schedules trigger runbooks at defined times, enabling routine operations like nightly backups or compliance checks to run automatically. Together, these components streamline cloud operations, enhance security, and ensure reliability. Use cases include automating patch management, enforcing resource configurations, and integrating with monitoring systems for proactive remediation. To build an Azure Automation runbook, you need to first create an automation account. For PowerShell-based runbooks, relevant modules like az.sql must be imported to enable execution. Users can securely include credentials and configure run as accounts within the automation account to manage access. Runbooks can be scheduled for automated execution, and Azure Automation provides a test pane to validate scripts in its execution context. The benefits of Azure Automation include streamlined task management, reduced manual effort, consistent execution, and scalability across cloud environments. Use cases range from automating VM lifecycle operations and database maintenance to deploying updates and integrating workflows across services for enterprise-wide automation. Elastic Jobs and Azure SQL Database provide a solution for scheduling and automating T-SQL tasks across multiple databases in environments where Azure SQL Database lacks a built-in job agent. Elastic Jobs require a dedicated job agent and metadata database to manage job definitions and execution history. They allow administrators to define target groups such as individual databases, elastic pools, or entire servers, even across different subscriptions and regions, offering scalability and centralized control. While Azure SQL Managed Instance includes SQL Server Agent for job scheduling, Elastic Jobs fill the gap for Azure SQL Database by enabling tasks like index maintenance, health checks, and data synchronization. This capability became especially valuable to DBAs early on as it allowed them to automate operations that were previously manual. Benefits include reduced administrative overhead, consistent task execution, and broad resource targeting. A typical use case is running nightly performance diagnostic across all of your production databases in multiple regions to ensure compliance and stability. Here we see the architecture and components of Elastic Jobs in Azure SQL and how a job agent reads job definitions from a job database and executes T-SQL scripts across a target group of databases, whether on a single server or within an elastic pool, or even across multiple subscriptions. The job status and output are written back to designated databases for tracking that can be run one time or defined on a schedule. Elastic Jobs are particularly valuable for automating routine tasks like backups, performance, tuning, and data synchronization across distributed environments. Elastic Jobs work similarly to SQL Server Agent Jobs, except that they're limited to executing T-SQL. The jobs work across all tiers of Azure SQL Database. SQL Agent Jobs continue to be used for task automation in SQL Server and are also included with Azure SQL Managed Instances. Azure Automation complements this by enabling broader process automation and configuration management across Azure and on-premises resources with full integration into the Azure platform and support for role-based access control. All of this is via Microsoft Intra. Azure Logic Apps are a cloud-based platform for building automated workflows that integrate apps, data, services, and systems across cloud, on-prem, and hybrid. A lot of these environments offer a visual designer to create workflows, and along with the built-in SQL Server connector, which supports the Azure SQL Database, Azure SQL Server, and Azure SQL Managed Instance. Although the connector has limited functionality, primarily the execute query action, it enables seamless integration with database services. Azure Logic Apps are part of Azure Integration Services and are especially valuable for enterprise and B2B scenarios, allowing organizations to connect legacy and modern systems efficiently. Benefits include reduced development time, scalable automation, and simplified integration across platforms. Use cases range from automating data transfers between systems, triggering alerts based on database changes, to orchestrating business processes like invoice approvals or customer onboarding workflows. Now it's time for our knowledge check. Question 1. What is the unit of execution for your Azure Automation account? Answer: runbook. Question 2, what scope can Azure policy be deployed to? Answer, subscription. Question 3, what is the name of the scope of the SQL Elastic job? Answer, target group. Join me now in seeing how to deploy an automation runbook to automatically rebuild indexes. Lab 13. Deploy an automation runbook to automatically rebuild indexes. This is actually a very practical lab. We're going to start by creating an automation runbook in creating an automation account. Where we're going to do this is inside Azure. So I'm in Azure, and as a matter of fact, it's not in the Azure SQL Database just yet, but we're going to build something here, connecting to a database here, this one in particular, but this needs actually to start in the automation account area. So if you don't see it here on the list, you can go up to the top and search automation accounts. That is where we're going to be able to create this automation account. So the automation account works throughout Azure. You can have it automate really something in PowerShell or Python. There's graphical versions of it also that might be very helpful. But as we get into the automation account here, I'm going to create one right now, and I'm going to put it in a resource group that we've been using. And we do have an automation account here that I'd like us to use here for this lab. So I'm going to enter that name here, and I could go into advanced and decide if I want it to use a managed identity. I could also go into networking and decide how this automation account will work. But none of these really need to be configured right now. So I'm simply going to review and create. And we'll see if it passed validation. And then what I'm going to do is I'm going to go ahead and create this. And when I create this, I will have to wait just a little bit for it to process and deploy. So here it goes. So it's currently created. I'm going to go into that resource. It's going to take me into the automation account here. And we have some configuration to do very shortly. But before we get into that, we're going to go back and get into one of our SQL databases here in Azure. So I'm going to leave this one open, and I'm going to come out here to my Azure SQL Database for a moment. And in particular, it's my Lab 2 option. Now I have to do a few things to make this work, because I initially went into my query editor, as you probably saw a little bit ago, with an issue connecting here. And in this way, it could not connect. So I had to set up some authentication to make this happen. But one of the other things that we should note here is I'm going to go out to the server, and now this initially set up Lab 2 server on the database server. And here we didn't set up any way to get connected to it. It was originally set here on disabled for public access, but I turned on selected networks. And I went in and I put our client IP address in. And so those two alone will help this to definitely get connected there. And that's what we have to do to make certain that we can get connected, that we can get authenticated. And I'm going to go back into Azure SQL here and back to that lab. Actually, our database here on Lab 2. And I'm going to go into the Run Query Editor for a moment here. And now I have a file that I'm going to load here, and it's our USP Adaptive Index defrag.sql file. And what I'm going to do is I've been able to connect, so I can do a little bit of management. I could go into the Management Studio too, that's another option, but I'm going to actually connect right here from my Microsoft Entra Authentication account that I set up for this. And once I get into this, then you will see I'm going to run a file. So there is the file. This is the file from lab number 13, lab files. Okay, and it's right here. And we're supposed to delete these two lines. And I'm going to make this in the notes so that we can get it to work here. But this is going to I'm going to drop it if it exists, and you can see kind of what it's doing there. There's a begin and creating a lot of tables. It's going to fill this up with a lot of data that we're going to be using, and we're going to run the defrag against it. So this script that we can use here and run for us, I'm going to go ahead and select it all. I'm going to copy it, and then I'm going to go and run it here in my little window for running queries. And yeah, it can take up to, it can take 3,335 lines here, and it's going to do it. And I'm going to create a stored procedure here, and I'm going to let it run for a moment. And you can see it's taking a little bit to run, and I could run it through the Management Studio, but I've been doing a lot of Management Studio, and I've had authentication problems here. And then depending on what I'm connecting to, the client has two. Its IP address has to be available, and then I have to get a way to authenticate. But I wanted you to see how I could do it here very cleanly with my Microsoft Enter ID account. And it's kind of a clean way to do it here too, besides the Management Studio. But it takes a little bit to run. It looks like it's running. Now it's supposed to create a bunch of stored procedures. And let's see, you can see a bunch of them right here. And we can, these are defragging stored procedures. And they're doing their work for us and cleaning and defragging our tables as needed. And what we can do here is we're going to use some of these for automation coming up. So what I'm going to do is I'm going to go back to the automation account. And I'm going to create tables here, and it's just an easy way to get back. I'm going to go back to the automation account that I created just a moment ago. And I'm going to go into the modules. And now what we have to remember is that we're going to be working with PowerShell and Python. For PowerShell in particular, though, we need to make certain that it has the modules added so that we can run PowerShell commands here. So just like it would be if we were on-prem and you wanted to use PowerShell, it has to have the modules for you, managing SQL Server or managing Exchange or managing SharePoint. You need to have PowerShell modules added for that to manage it here, even in the cloud. So it's very helpful. And what I'm going to do, I think, is I may have added it earlier. So I'm going to go back and check to see the one called SQL Server. And let me write this. And if it's not here, I can always add it here. Okay, so I'm going to add that module in. And so the PowerShell command here, I'm going to go browse the gallery. I'm going to type SQL Server and see if I can find it in the list to add the modules in for PowerShell. And there you go. There it is right there, SQL Server, one word. And I'm going to add that one in. And I could also take a look at some of the other options that are in here, depending on what modules I'd like to add. But I'm going to add in SQL Server. And you can see some of the commandlets that you can run, adding that module in for PowerShell. And as I tell you there, we want the ones to work with SQL, so this looks pretty good. So I'm going to go ahead and select this. And then I'm going to take it, it's going to take just a moment to get itself together. And then I'm going to go use the latest version if I can. So that is the recommended to use here. I'm going to try the latest version. So let's see if we can do that, if it would validate work here for us. So I might have to make some changes. Let's see what happens. The latest version is available. And then what I'm going to do is I'm going to go ahead and import this in. And it's going to take a moment to import it into our automation account here and see if it's listed. Now, if I do a search now for SQL Server, I should hopefully be able to find it. Yeah, it's in the list. Nope. So, whoops. Now let's refresh it a couple times. Let's see if it's there. But it should be there. Run it a couple more times. May just take a moment. So it may be there, it just may be not showing up right now. But we did add it, and so we should be okay. But usually I do check, and I think there was a number of pages, so it may take a little bit. And the page is right there. Okay, so I'm going to scroll through and see if I can find it. Could do another search. I'm going to hit enter and see if I can find it. It might just take it a little bit longer here to add this in. Might be a little slow at adding, but I'm going to go ahead and browse the gallery. I think I added it, so I think I could wait a little moment and test it. Can also come back here. So what we're going to do is we're now going to go into our, let's see, we're going to do a little deeper dive here into our credentials. So here under shared resources is credentials, and in credentials you can add a credential to run this. We can also give it a name, what we want it to do. SQL Server user is going to use the name of this credential. And then what we can also do is we can put in the username for SQL admin. That will be our user for this account that we'll use here to run SQL. And then I'm going to put a password in, so it lets me see if we can get that work done here. Let's get the password in, and hopefully I can match these up as I'm talking. Sometimes it takes a little bit, as you know, to type it in correctly, but hopefully that's clean right there. Okay, I got a new credential created, and now we can see it. So I'm hoping the module is there. If not, we can come back. But I thought I okayed it, so it might just take a little bit, might be a little slow to add it in. Okay, so hopefully we'll see that. And then we're going to go and use the Create PowerShell Runbook here. What I'm going to do is I'm going to go in the portal here, and I'm going to take a look at my server, and I'm going to go back in here and have a name for our server right here. And I'm going to need this, so I'm going to copy it. And I'm going to be using this, and I'm going to come back into this in a bit here, but I'm going to need this name for the server. So we'll come back to that. And then I'm going to go to do, where we're going is, I'm going to go ahead here into our runbook area. So we'll go back into the runbooks on the automation here. And we already have some default runbooks here. I'm going to add to this list here. We have a graphical PowerShell. We have some little tutorials here for Python and for graphical Python and PowerShell. But I'm going to create a runbook. And then when we create this runbook, what I'm going to do is I'm going to give it an index maintenance name here. And then the runbook type, you'll see all different types that you can choose from. Graphical versions of PowerShell, PowerShell workflow, there's PowerShell, PowerShell workflow, and then also Python. We're just going to use the straight PowerShell for right now, but we could come and put a description, and we're going to go ahead and create this runbook right here. So it flunked validation because I forgot to put the runtime in. Okay, sorry about that. Anything with a little asterisk we need to note here. It needs that in order to move forward. So we saw that we didn't pass validation. We just looked at the red dot, and it was easy enough to kind of go back and fix it. Sometimes it's harder, and especially when there's a lot of pages. So now we're here, and we have some PowerShell that we'd like to work with. So when we get to this runbook, what we're going to do is we're going to go into this and copy the same code from our lab right here. So what I want to do is paste this in, and this is going to use AdventureWorks Database LT, and it's going to use the credential we just created called SQL Server user, and then we're going to look off and we're going to see that it can get connected to the SQL Server instance using the username and our password, and then it's going to go and run this stored procedure. You can see it right there. It's going to execute that. So we could have this stored procedure run on a timer, and that's an idea that we could work with, have it run on a timer. Okay, so it looks pretty good here. I'm going to save it first. Then after it's saved, I'm going to go ahead and publish it. And I'm going to go ahead and publish this right there. It just takes a moment to publish, and I just remembered, I think I need to put one more thing inside of it. So let's go back and edit it, and I'm going to edit it here in the portal. And as I get back into where I was, I need to put the server name in right there. So I left that out. That's going to not run with that. So I'm going to go ahead and save that again. And then I'm going to publish it again. And now it's published. And now what I want to do is I can schedule this to run, but I'm on it right now, and I'm going to go in and I'm going to schedule it to run. And when I schedule this, I can add a schedule, and it can be pretty versatile that a lot of people can use this. And I'm going to choose the option that's right here. I'm going to have it add a schedule. And what I'm going to do is I'm going to have a number of names I'm going to pop in here. So we're going to call it Daily Index Defrag. This is a description that is always nice to have. And then I could also add in here Daily Index Defragging. We're going to give it a start for tomorrow, and we're going to have it start tomorrow at 4 a.m. So we're going to put this in that, and we're going to put the time zone in there. And I'm going to have it reoccur, and we can have it reoccur maybe once a day. And we can set that, and then we can tell it when we want it to expire. We only want it to run one time. We could set it up how we want it to work here. I'm going to hit create, and then we have the schedule created. So we can also do one with parameters here, but I'm going to go back into our runbook, and there I will take a look even further back. There's one account, and we'll move into our account here, and we'll take a look at our runbook. So this is the runbook right here. Index maintenance, I'm going to select it. It's listed as new, but I also want to see if it runs. So I'm going to go ahead and start it. I could wait until 4 a.m., but I won't until tomorrow. I think you'll be able to do it easier from here. I'm going to start it. And from right here, you can see it's been queued. And I get impatient. I can refresh it. I'll show some input-output errors warnings if it has them. If it has issues, it's queued right now. I'm going to refresh it. It should automatically update, but I'm ready with that refresh button in case it doesn't. There it shows it's starting, and we will hopefully see a little bit more on it as we go through. So it's starting it up, and then it starts. It will start running, and we'll just wait a little bit to see what happens. And we definitely do want to test it to make certain it works. I put the name of it in, and the address to the server and the database. So that was helpful. I know sometimes we forget things, so we need to make certain we get it to work. And then the modules were there for us to use, and probably just a late refresh here. So it's completed, so that's pretty. Okay, we can look to see the output, and we might see a few things. So there might be a little bit of an issue here, but it did complete. And we did get, did we get any warnings? No warnings. A little bit of a log there, and we can go back and figure out, what it's telling us. Here, the invoke SQL is not recognized as, something wrong with that. So not recognized as the name of the commandlet. So maybe we did have a problem doing those commandlets. So I'm going to go back to my account here, and I'm going to go into our modules area and see maybe we put somehow, maybe it just didn't pull it in. So we're going to see if we can find that SQL Server option again. I'll do a search for that. So I thought I pulled this in. I selected it. That might have been why we were getting an error there. And I'm going to rerun this here with the latest version. And then I'm going to try this one here. And it could be the reason why this is having a problem. We have to do a little bit more digging, but you get the idea. It's imported, the import started, so it takes a little bit to pull it in. And so that might be part of this process. But I think that might be something happened during the pulling process. of that SQL Server module. So I could try another version if need be, but the import is in progress. So it's taking a little bit. We never got to show, but it was in process of importing. So that might take a little bit here. And this is definitely one of our modules that you can add it into. And it's just the import takes a little bit, and then I can go back and rerun it and test it again. But I think you get the idea with this. We need to make certain that we get that module added, and it may take a little bit for that to actually happen. So it'll refresh it when it's ready. And okay, I'm hoping that you like this section. You got a lot of this to work, and it just takes a lot of patience. A little bit to import, a little bit for things to be created. Timing is everything. And it's definitely one of our commands that we can do and you might find helpful, the defrag option. And so I hope you like this area. And again, looking forward to seeing you in our next section. Thank you so much. For more information on how to create an Azure Automation Runbook or a SQL Server agent or working with maintenance solutions from Ola Hellegren, please see the links we have here. In this section, we learned how to automate database resource deployment using ARM templates, Bicep, PowerShell, Azure CLI, and Quick Start templates. We also explored SQL Server agent job creation and management, including maintenance tasks and alert configurations. And finally, we covered Azure PaaS automation using Azure Automation, Elastic Jobs, and Logic Apps, including building runbooks for scheduled and scalable task execution. Thank you so much for viewing this session, and I hope to see you in the next.